Okay, welcome to JEE Star IIT KGP YouTube channel. So here I discuss a very nice problem, a very nice conceptual problem about relative velocity and displacement. Okay, so what is the question? So here there is a particle. There is a particle. This particle is going in this direction, and this particle is going in this direction with velocity v1. This v1, and this is v2. And initially they are at distance L2 from this origin. We have defined the axis here, okay, and this angle is theta given, and this is L1, okay, fine. So and now, so first of all, I defined these position vectors for these two. So for this one, the position vector is L2 I cap. For particle 1, the position vector is, we are breaking it into component L1. So this is going to be L1 sin theta, okay, L1 sin theta, and this is going to be this one, like this one is going to be L1 cos theta, okay. And also we have written the velocity vectors. Also for in that case too, I have broken this component, this v1, into its components, perpendicular components along this axis, and these are the initial velocity vectors, okay. So the relative velocity and relative displacement between these particles, like the relative distance between these particles, I have written as v1 minus v2 and x1 minus x2. So these are the ones, okay. Now let us calculate the first. So understand the thing. So after a time t, what will happen if we are seeing this from here, okay, sorry, it is okay. So if we are seeing from this point, okay, if we see it at this particle 2, so I am seeing relative to this, relative to particle 2, so this particle 2 will be at rest, but this particle 1 will move along the direction of relative velocity. So after a time t, a point of time will come when I will have the minimum distance between this and these two particles, okay. And in that case, when I will get the minimum distance, when this displacement vector between this, like or you can say the distance vector or the displacement vector between these particles, the relative distance between these particles, when this vector and the relative velocity vector after a time t will be perpendicular to each other, okay. So we have written the condition here, v12 at time t and x12 at time t equal, and their dot product is 0, because these two are perpendicular at the minimum condition. And this one after a time t will be, this one is constant, okay, and x12 after a time t will be, this is the x12 initial plus this is the v12 t. So this one plus this one by triangle law of vector addition, so we will get this x minimum vector. So we can write it as this one, okay, and we are getting the dot product. So this is, and from here we can write the t minimum equals to this one, okay. And if you put the all the values of these vectors, so you will get this one. You can calculate yourself, okay. So for x minimum, like for finding the minimum distance between these particles, so for in that case you can do this also, putting the value of this t minimum, but this will be very lengthy, okay. So what is a very good method to do this is for x minimum, okay, we know at about this point, if this point is at rest and this is moving at a constant velocity, this is the velocity isn't changing, right? So we can say that the angular momentum will be conserved, because the net torque about this point is 0, external torque about this point is 0, so you can conserve the angular momentum. So that is what I have done here. x12 cross v12 is this the initial angular momentum, and this is the final angular momentum when it will be at minimum distance, okay. And as this and this are perpendicular, so I have written like this, okay, fine. And also we need not like write like this, we can do the direct cross product of these two vectors, that will be easier, okay. And from here we will get the x minimum, the magnitude of x12 initial cross v12 initial by v12 initial and its magnitude, okay. So if you put these values and calculate this cross product, you will get a direct answer of this x minimum. So this is a I think a better method of doing this, okay. In case you are given this v1 v2 these all values, you will be able to calculate these values easier and faster. As I have taken the variables, so it is looking a bit lengthy, but when the data will be given in numbers and like this, you can calculate it very fast. Okay, so that's it for today. Subscribe to my channel for more interesting topics and more interesting problems. Okay.